it's Miss Rogers, in case you've forgotten what I look like by now. First of all, I miss you guys very much. Second of all, I'm actually really excited that we get to do a little bit of stuff like this because we can do some things that we might not have gotten to do in the classroom. For those of you that are not normally in my classroom, like I said, I'm Miss Rogers. You'll see me in the mornings on the beginning of the hallway. So we're just going to do some different science experiments and let you watch them and see what happens. And this is really just meant to be something fun, just something that you can kind of take a break from your other studies and pull up a video and watch all these kind of different things happen. So I'm calling it Stimming Around with Miss Rogers. Get it? Because we're all just sitting around? No? Okay, bad joke. Okay. So this one, we are going to look at density. You might say, Miss Rogers, what's density? Density is how much space an object takes up in relation to how much matter is in that object. Now, everything is made up of teeny tiny molecules. Okay, so what that means is that sometimes molecules are really compact. Okay, so that would be like a solid. So a solid you're able to hold in your hand because all those molecules are packed tight together and sticking together to make something into a solid. Now, if I had something like a liquid, whenever I try to hold water, it all falls out of my hand because the molecules are more spread apart. So they're not going to stay compact like a solid would. It's all just going to kind of drip. You can hold a little bit of water in your hands because the molecules are a little bit together. And then in a gas, they are completely spread out, which is why you can't hold a gas. Okay, so solids are when molecules are more compact, then they're going to be high density. And then it's going to go there from gas to a lower density. So, more compact means it's more dense. Less compact, less dense. Okay, so let's look at some things. Okay, so I have a bowl of M&Ms, and then I have a bowl of crunched up cookies. Okay, so which one do you think would weigh more? Okay, so some of you may think that bigger chunks would weigh more, but actually the M&Ms weigh more, and that makes them more dense because they are more compacted together than these cookies are. You can see in the cookies there's a lot more space in there than in the M&Ms. The M&Ms, there's a lot less space because they're smaller and compacted together. Hopefully that makes sense. Okay, so liquids also have a certain amount of density to them. So what we're going to do is we're going to take this jar and we are going to stack our liquids. Yes, I've said stack. Now you might be thinking Miss Rogers has lost her mind because how are you going to stack liquids on top of each other? Liquids can stack if you do it by their density. So liquids that are more dense are going to be more compacted together, so they're going to sit at the bottom. If a liquid has less density, then the molecules are going to float and sit on the top. So we're going to start with honey, and I'm going to pour it into, move some of these out of the way so you can see. Okay, so I have some honey, and I'm going to pour it just directly into the middle of the jar. Honey is very thick, so it might take a little bit. Here it comes. And I'm going to pour it into this jar. Careful not to touch the sides because that'll affect the other liquids. see my house leans a little bit. Actually, going to get a little bit more honey. There we go. Okay, so the next one that I'm going to put in the bowl is called corn syrup. Corn syrup is in a lot of the juices and snacks and stuff that you guys eat. And so enough in these cups. So add just a little bit more. Okay, so it's hard to see the colors a little bit, but they are starting to stack. So this one should help. And this is maple syrup. So we're going to pour that in. Maybe a little bit more. We always like more. There we go. So now you can really kind of see the colors a little bit as they are starting to stack, not mix. Okay. Next one is just a glass of regular whole milk. Put that on there and it stacks. Okay, so this one is just your regular dish soap. Almost starts to mix and then it floats to the top because of those molecules that are less dense are going to come up to the top of the jar. Okay, and then we just have some regular water that comes up to the top. And then the last one we're doing is just some vegetable oil. So I know it's a little bit difficult to see some of the colors. I'm going to try and move the jar a little bit closer. So you can see here how the different colors are stacking together. Now, the more I leave it, and shake it, it's going to start to mix. But you can see the honey on the bottom, that corn syrup in the middle, maple syrup, milk, the dish soap, water, and then the oil is sitting on the top. So, liquids have density and they can stack based on whether it is a high density liquid or a low density liquid. Now, there's one other thing I'm going to show you. We're going to do an underwater volcano. I'll be right back. Here I have a glass of cold water, and I have a small glass of hot water. Now, what I want you to pay attention to is the reaction of when the hot water mixes with the cold water. Okay, so see how it all came up to the top? So when the heat mixes with the cold water, it causes all of the molecules to go up to this top area, almost like looking like an underwater volcano, because it just came straight up to the top. And it's kind of sitting at the top. You see the bottom is still clear. It's not mixing to the bottom because of how it reacts together. Okay, that is all for this round of videos. Next week we're going to look at the water cycle and how a storm works and things like that. And I'll see you guys next time. Keep up your studies. I hope this was fun. And if there's anything you'd like me to try or an experiment you want me to do, just let me know and I will do my best. Love you guys.